Welcome back. Now let's see the construction of the sectional views when the objects are cut by imaginary vertical plane at different orientations. Consider an example of a cone resting on its base on HP. A cutting plane perpendicular to both HP and VP cuts the cone to the left of the axis. Observe that the projection of section plane appears as vertical lines on both HP and VP. The true shape of the cut section appears on an auxiliary plane parallel to the section plane. So let's construct the views. Here, plan of the cone is a circle which gives the true shape of base of the cone. We will divide it into 8 equal parts along the circumference. Now, we will project the details from the plan above the line XY, forming the elevation, which is a triangle with base A', E' on line XY. Observe the cutting plane cuts the plan of the cone at 1, 2, 3, 4, 5 and the elevation at 1', 2', 3', 4', 5'. To obtain the true shape of the section, we'll draw projectors from these points to the side view so that they intersect at 1', 2', 3', 4', 5'. Observe, joining these points by a smooth curve represents the true shape of the section. And this is the complete solution for the cone. Fine. Now let's crack another problem. A cylinder is resting on HP and a section plane perpendicular to VP and inclined at 30 degrees to HP cuts it at its mid-axis. Here, as you already know, its top view will be a circle and its front view will be a rectangle. As the section plane is perpendicular to VP and inclined to HP, the elevation on the auxiliary plane gives the true shape of the cut section of the cylinder. This projection of the section plane appears as an inclined line on VP. So, let's construct the sectional view of the cylinder. Draw the plan, which is a circle, and divide it into 8 equal parts. Now, project these points above the line XY to obtain the elevation of the cylinder, which is a rectangle. The elevation of the cutting plane will be a trace line AA inclined at 30 degrees to XY. It cuts the cylinder at 1', 2', 3', 4', 5', 6', 7', 8'. Project these points onto the plan as 1, 2, 3, 4, 5, 6, 7, 8. Now, draw a line X1, Y1 parallel to AA. Then, the lines from the points on AA are extended further, meeting line X1, Y1 perpendicularly. These points are A1', B1', C1', D1', E1'. Next, measure the distance P'1 and mark it on the line 1', A1' to obtain the point 1'. Similarly, obtain points 2', 3', 4', 5', 6', 7', and 8'. Join these points by a smooth curve and hatch the enclosed figure. This is the true shape of the cut section. Observe, as the section plane cuts across the whole section, the plan itself is the sectional view. So friends, the sectional views are truly helpful in building internal and hidden features of the complex mechanical parts. The cutting plane technique gives the true shapes of the cut sections by revealing the interior elements of the solids.